Hello students, welcome back to our paper CHO 5403. We are discussing about chiron approach, in which we have discussed about what is meant by chiron approach and how the cheaply available chiral molecules can be used for the preparing expensive unnatural natural products or chiral molecules. So friends, we have started discussing synthesis of some important unnatural natural products which are very useful in various kinds of organic transformation. So we have started with RNS epichlorohydrin from D-mannitol. Today we are going to discuss about the synthesis of Shikimic acid from d-arabinose. So friends, you can see here the structure of d-arabinose is compound number 1, which on treatment with H2 nickel, or I will say H2 rani nickel, it will be converted to arabinol, that is conversion of this CHO into C2 CH2OH. Okay, so this is a compound number 2, which is a arabitol. So arabitol is then treated with the triphenyl methyl trichloride into 1,5 ditretyl derivative. So this it is converted into 1,5 ditretyl derivative by treatment with the triphenyl methyl chloride. Okay, triphenyl methyl chloride, we get this ditretyl derivative, which upon reaction with benzyl chloride and KOH will now protect these secondary alcohols. Okay, first we protected the primary alcohols. Now this benzyl chloride and KOH will preferentially protect this secondary alcoholic OH groups. Okay, so we have benzyl and benzyl, that is three OH groups are protected by the benzyl in presence of benzyl chloride and KOH. So next step is the deprotection of this trityl group. So trityl group is easily deprotected in presence of 70% of acetic acid. So now only the secondary OH groups are protected and the primary OH groups are not protected or free. So friends, next reaction is to convert this OH into OTS. So converting this CH2OH into OTS, we are using paratoluene sulfonyl chloride. Previously it was written as TOSCl, but nowadays the denotation is changed and now we can write it like TSCl. So this is nothing but it's a TS protection or paratoluene sulfonyl group is over here. Now primary alcoholic groups are protected with the OTS and the secondary with the benzyl protected. Okay, so friends, the next step is very important, in which we are using three equivalents of this methylene triphenyl phosphorane. So this is a Wittig reagent which will convert this compound number 6 into this cyclic ylide. Okay, this cyclic ylide is formed when treatment with this CH2 double bond PPH3 with this CH2 OTS and CH2 OTS. Once we get this cyclic ylide, the next reaction is again Wittig reaction with the formaldehyde. So when formaldehyde reacted with this cyclic ylide, we get CH2 over here. Okay, we get this exocyclic double bond over here. Now the next reaction is to deprotect this benzyl protected OH groups. Now benzyl protected OH group are deprotected with the help of sodium in a liquid ammonia. Okay, this is simple the reduction of this simple ether to alcohol. Now we have compound number 10, which on treatment with acetic anhydride and pyridine will convert this OH group into OAC group. So we get this triacetyl derivative, compound number 11. So now the next reaction on the 11 is reaction with the OSO4, osmium tetroxide, and tetroxide and sodium periodate. So friends, this reaction will now convert this CH2 carbon carbon double bond into carbonyl group. As you know that converting this double bond to carbonyl group it is the simple oxidation with the OSO4. So double bond is now converted to this alcohol, sorry, ketone, and then again with the formaldehyde derivative for the CH2. So this is a simple OSO4 oxidation of a double bond to carbonyl. Then next step is very important. This is a cyanohydrin formation. So once we get the cyanohydrin formation with treatment with the SCN, the compound number 13 is subjected for the dehydration, that is a minus H2O in presence of POCl3. So POCl3 will convert this OH into good living group, and this hydrogen over here is now going with the OH, and we get the loss of hydrogen water molecule, and we get this intermediate which is known as Shikimonitride. Okay, triacetyl Shikimonitride. So this triacetyl Shikimonitride, when treated with the NaOH, it will hydrolyze this acetyl groups, and also it will hydrolyze this CN into COH. So once this hydrolysis is taken place, we get this 3 OH group and 1 COH group with the double bond. So the compound number 9 is nothing but it is a Shikimic acid. So friends, this is very nice synthesis of Shikimic acid from d-arabinose. Friends, when we prepare Shikimic acid from d-arabinose, compound number 13 is used for the preparation of quinic acid also. So this quinic acid is prepared by the compound number 13. When this compound number 13 is treated with acetic anhydride and pyridine, the OH group is acylated. Okay, the OH group from cyanohydrin is acylated, and then next step is conversion of this CN to amide by treating it with the HBr acetic acid and simple hydrolysis. So CN is converted to CONH2. On further treatment with the N2O3, it will converted, the amide group is converted to COOH group. Okay, now this is a simple hydrolysis of CN to COOH, but we need to protect this OAC protected groups. So we are going for the HBr acetic acid to amide, and then amide to acid. Finally, when we get this kind of derivative, the tetra acetyl derivative, this tetraacetyl derivative now hydrolyzed with the NaOH2O, we get the deprotection of all 4 OH group, and we get this kind of compound, compound number 17. 17 is known as quinic acid. So this is how we are going to prepare Shikimic acid and quinic acid from d-arabinose.